All right, good morning. Today we're going to be going over natural logarithms. Natural logarithms use a base of e. Oh, oh well, exactly. Um, Base e is a special irrational number whose value is approximately equal to 2.718. All properties of logarithms apply to natural logarithms because they all are logarithms. So we have something that looks like log base e of x. But you won't see it written as log base e. You'll see it written as ln of x. So ln stands for log base e. So let's talk about what ln of e is. That's equal to log base e of e. So what is that equal to? 1. Okay? So ln of e is equal to 1. Like I said, all the properties for logarithms apply. So the first property is the power property. Log base b of, it's the product property. Log base b of mn is equal to log base b of m plus log base b of n. Well, in this case, the base would be equal to e. Everybody understand that? Okay. The other properties also apply. These are all properties that we've learned. We said common logarithms use base 10. So we might have something that looked like log base 10 of 24 is equal to log base 10 over log base 10 of 6. Nobody writes the 10. So when we talk about these problems, I'll wait till y'all get them on your paper. You'll notice here I have e raised to x is equal to 5. That's an exponential function. It's not a logarithmic function. But the base is e. So if you were to write it in logarithmic form, you would say log base e of 5 is equal to x. But remember that log base e is equal to ln. So you would see this written as ln of 5 is equal to x. Now, I don't think my calculator is working for whatever reason. Not good. But if you take your calculator, everybody take their calculator out. If you take your calculator, you'll find the ln button. If you put in ln of 5, you get 1.6094. All right, so let's look at the next problem. What do we have here? Once again, we have an exponential function which has a base of e raised to a logarithmic function which is the same as e raised to log base e of 7. So what would all that be equal to? Right, 7. Everybody okay with that? My third example says ln of e raised to 4x plus 3. 4x plus 3 is the answer to the problem. If this is log base e of e raised to 4x plus 3, so the whole thing has to be this. Alright, so on the next column you have 5e raised to the negative x minus 7 is equal to 2. The first thing you want to do is isolate the e. So what will we do first? Add 7. 5 by 5. We want to write it as a logarithm to solve it. So we're going to say ln of e raised to the negative x to 9/5. We want to move negative x to the front of the logarithm. And does anybody remember what ln of e is equal to? 1. So, huh? Oh, I screwed it up. Sorry. All right, so we isolated. Let's go back to the beginning. Oh, it's on the top. So we isolated our e. Next, we want to use the equality property. So we would say ln of e raised to the negative x is equal to ln of 9/5. We move our negative x to the front of the logarithm, we have this. But ln of e is equal to 1. So what we have is negative x times 1 is equal to ln of 9/5. ln of e. Remember, that's log base e of e. ln of e is equal to that. That's why it's equal to 1. Alright, so if we divide by negative 1, right, we get x is equal to negative ln of 9/5. So we put that in our calculator, we get negative 0.5878. Y'all plug it in your calculator since mine's not working. Yes? negative, then ln, and then 9 divided by 5, close the parentheses. So we're going to spend the next 3 days on word problems, growth and decay word problems that have to do with investment, and other word problems. I would write this down, yes. Suppose you deposit $500 in an account, paying 11% interest, compounding continuously when you're 15 years of age. What will the balance be when you're 65 years old? Well, when you think about it, $500 is less than $50 a month. So I think a 15-year-old can afford $50 a month if you get an allowance or you have a part-time job. But let's find out how much money we'll have. The equation that we're using is A is equal to P raised to the R2. Let's talk about what these all stand for. P is equal to the principal. Principal is the amount that you invest, or the amount of the investment. R is equal to the rate. It is a percentage. You need to change to a decimal. C is time. And A is the ending amount. Or the amount that you'll have at the end of the investment. Principal is the amount of the investment. All right, so what is the principal? How much money are you investing? $500. Good. Well, the principal is $500. What is the rate? 11%. And what is the time? All right. We'll go back here. We have A is equal to P R2. So A is equal to, we don't know A, that's what we're looking for. So we're going to invest $500. The rate changed to a decimal, 11. And the time is 6 years. So we'll plug this in our calculator. Obviously, dollars and cents would have how many decimal places? 2. So after 6 years, your $500 is $123,345. That's a lot of money for a $500 investment. Okay? If you did this every year for 10 years, from the age of 15 to the age of 25, and you invested $500 every year, you would have over $700,000 for basically a $500 investment for 10 years, which is $5,000. So the moral to this story is invest your money at an early age. If you waited until you were 40 or even 50 to invest that $500, you wouldn't have very much money. In fact, all of y'all put this in the calculator. 500 raised to the decimal 11, and let's change it to say 40, so 25. Right? So what would you have after 25 years? So that's if you invested at 40. And how much would you have? How much? Say less. So if you waited and invested your money at the age of 40 and left it there until you were 65, you'd only have $7,821. So like I said, the moral to this story is to invest your money at an early age. Right. All right. So example 6 says ln of 5x is equal to 4. So what's the base? What's the x? All that is 5x. So x equals to 4 divided by 5, which is 10.9196. All right. All right. So we're on to example 8. What is base? Yes. All right. It's important to remember to keep x times what we say about the inequality. So x greater than b raised to the 2 plus 1. So x greater than 1.165. Everybody okay with that? Do we need a restriction? No. We'll always have positive numbers because it's greater than 1. All right, so let's look at the start dot. It is a logarithmic function, so we need to consider the restrictions. Remember that a logarithmic function, that the domain is made up of all positive real numbers. So we're going to say x minus 1 is greater than 0, or x is greater than 1. Always greater than. All right, because the domain is made up of all positive real numbers. 0 is neither positive nor negative. So we have e is log base b of x minus raised to negative 2 plus 1. So I get x less than 1.1353. But I have to have the restrictions because this says x is less than that, and it has to be greater than 1. Everybody okay with that? Alright, so let's look at this problem, and it is a homework problem. My last example. Probably Alright, first thing you want to do is isolate the e. So what are we going to do first? So the next thing we want to do is use the equality property. ln of raised to x ln of 3. I usually use base e for all of my problems, unless it specifically calls for base 10. So I have x times ln of e is equal to ln of 3. Remember that ln of e is equal to how much? 1. So ln of e is equal to 1. So this is x is equal to ln of 3. You plug that in your calculator and you'll get that x is equal to 1.0986. Everybody okay with that one? All right. Let me do problem number 53 first. Like I said, all the properties for logarithms apply. So this problem number 53 says ln of x plus ln of x plus 4 is equal to ln of 5. If you're having a hard time with the ln, just change it to log base e. That might be helpful. So the plus means to multiply. So this is x times x plus 4 is equal to ln of 5. Because I have a single logarithm on either side of the equation, I can use the equality property and say x times x plus 4 is equal to 5. So I have x squared plus 4x is equal to 5. So x squared plus 4x minus 5 equals 0. When you factor this, you get x plus 5 and x minus 1. So x is equal to negative 5 or x is equal to positive 1. Well, is x going to be equal to a negative 5? No. This is not an answer. This is an answer. Because remember, the domain is made up of all positive real numbers, and if you plug in negative 5 in here, you get a negative number. Everybody okay with that one? So we'll go back to the first page for the homework exercises. Alright, so once again, the homework is on page 557, 1 through 61, all 64 and 65. It shouldn't take that long, y'all.